So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see the problem named Maximum Subarray Sum. Here we have given an array. We have to generate all the subarrays first and then we have to find the sum of that subarrays. After that we have to return the maximum of it. So let's say if we have an array, I'll explain you with the small example. Let's say we have an array which includes 1, -9, 3 and 5. So the sub arrays will be 1, 1 minus 9, 1 minus 9, 3, 1 minus 9, 3, 5. Then we have -9. Now we have generated all the sub arrays. After that we have to find the sum of all the sub arrays. So the sum will be 1. For this it will be -8. Then for this it will be -5. For this it will be 0. For this it will be -9. Then we have -6. Then we have -1. For this it will be 3, 8 and then 5. So we can say that among this sum who is maximum is 8, right? So we have to return 8 as an answer. Okay, similarly we have to find the maximum subarray sum for this array. So I hope you got the question. Okay, now let's see how we can solve this problem. But before that, let me tell you that we have started a series on DSA problem. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be helpful for you. If you are preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Thank you. Now, in the previous lecture, I have already shown that how to generate all the subarrays and how we can find the sum of all the subarrays. Okay. Now, what you can do after doing that, you can put all this sum in an array. Okay, I hope you know that what will be the size of the array. It will be n into n plus 1 by 2. Okay, this will be the size of the array. Now what you can do, you can simply run one for loop to find the maximum of all the elements and then simply return that element. Okay, so I have shown you the two approaches. One was taking order of n cube, the time complexity, and the space complexity was constant. The second approach was taking order of n square, and but the space complexity was order of n. Okay, this we have done using the prefix sum approach. Okay, now today we are going to see the third approach, in which it will take order of n as a time complexity and a time complexity of order of 1. Okay, so let's start. Now let's see first case. Let's say in an array, if we have all elements as positive. Okay, so what will be the maximum subarray sum? It will be sum of every element, right? Since it is containing all the positive elements, let's say 1, 9, 2, then the maximum subarray will be sum of all the elements, that will be 12, right? Similarly, let's see the second condition, or let's say second case. Here in an array, let's say if we have all the elements as negative, so -1, -9 and -2. So here in this case, what should be the answer? I'll give you 10 seconds. Comment down your answer. So the answer will be maximum number, right? Because it is containing negative numbers. So for this, the maximum number is -1. So the answer here will be -1. Okay, maximum subarray will be -1. Now let's see the third case. Let's say if an array has some positive elements and after that some negative elements. Okay, here in this case, here in this case, the maximum subarray sum will be a sum of all positive elements, right? So here the answer will be sum of positive elements. Now let's see the fourth condition or fourth case. At start, let's say if we have negative elements, okay, and after some point we have positive elements. So here also we can see that the answer will be sum of positive elements. This part. Why? Because let's take one example. -1, -9, -2, and then let's say we have 20. Now till this point this sum will be -1. Till this point this sum will be -10, right? Till this point this sum will be -12. Now till this point this sum will be -12 plus 20. So this will be 8, right? Now we can see that this -12 is actually hampering our answer. So we are adding this negative value to our positive sum, right? So due to this we are getting answer as 8, but actually the answer should be 20, right? So observing this behavior, if this sum is negative, if the sum is negative, we will not propagate this negative value forward. Okay, so this is what Kadane's algorithm says. After calculating the sum, if we found this sum is lesser than 0, that is negative, then we will simply not carry forward that sum. We will simply reassign the sum to 0 again. Okay, if you don't get it, don't worry, I'll be explaining with the help of an example. Now let's say we have an array. Now since we want to find the maximum subarray sum, we will be having sum which will be initially 0 and answer. This will be the actual answer. This will be assigned to -infinity because we want to find the maximum subarray sum. So according to the case 2, here we can see that the maximum subarray sum is -1, not 0, right? So we are still returning the maximum subarray sum as a maximum number, not 0. So here we are assigning answer as -infinity. Now let's start. Now till this point the sum is -2, right? So we will see -2 will be the sum, and we will be comparing answer with sum. If it is greater, then we will update our answer. Since we know that the -infinity is much lesser than -2, right? So we will update our answer. But we can see that we can't actually propagate this -2 forward because this will hamper our answer. So we will be assigning sum to 0 again, and we will be moving forward. Now here the sum is 0 and we are actually including this one. So due to this sum will be 1 now. 0 plus 1 will be 1. Okay, now again we will be comparing sum with answer. Now we got answer as 1. So you can see that till this point the maximum subarray sum is 1. All right, let's move forward. Till this point, let's see, we have sum as 1 and we are adding -3 to it. So the answer will be -2. All right, so update the sum, then compare. We can see that by comparing answer is still greater, right? So we will not do anything, but actually we can't propagate this -2 forward because it will hamper our answer. So we will reassign the sum to 0 again. Okay, let's move forward. Now this point the sum is 0, and if we include 4 to it, this sum will be 4. Again compare, here the sum is greater, so simply update our answer. Okay, and then move forward. Now in that sum we have to include -1. If you include it, the answer will be the answer will be 3, right? 4 minus 1 will be 3. But here we can see that the answer is positive. Sorry, here we can see that the sum is positive. Not, this will not hamper our answer, right? The negative sum is actually hampering our answer. So we will not do anything. We will simply move forward. Now we have to include 2 to our sum. So 3 plus 2 will be 5. Now we can see that the answer is smaller, which is 4. So we have to update it to 5. Again move forward. Now we have to include 1 to our sum. So 5 plus 1 will be 6. So update the sum to 6. Again compare sum with answer. Here we will be updating answer to 6 because it is greater. Okay, so actually I forgot to mention this is minus. Now let's include -5 as well. So 6 minus 5 will be 1. Right, so update sum to 1 and compare. Here we can see that after comparing, 6 is still greater, right? So we will not do anything, we will simply move forward. Now we have to include this 4 to 1, so this will be 5, right? So 1 plus 4 will be 5. Again compare, 6 is still greater, so we will not do anything and we will terminate the loop. Now here we can see that actually the maximum subarray sum will be 6 only, because if we do the sum of these elements, the sum is 6, right? If you calculate all the subarray sum, you will be getting 6 as an answer. Okay, so in this way you can solve this problem. I'll write the pseudocode for I will be starting from 0 and it will be gone till n. Now update the sum, that is sum equals to a of I. If the sum is lesser than 0, then reassign the sum to 0. If sum is greater than answer, then update the answer. And that's it, we are done. So this is what Kadane's algorithm says. If you see the time complexity, it will be order of n, and since we didn't use any space, so the space will be order of 1. Okay, this is a simple approach. That means if the sum is negative, simply reassign the sum to 0. Okay, that's it. So that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.